Is up, bitches, hoes, and motherfuckers? We are live. Nice. How are you all doing? I hope you all are doing fantastic. Alrighty then. Here's the thing. Antonio has been kind of a jackass and making a complete jackass out of himself over the past few weeks. You've seen on my YouTube channel. He's gotten a lot of shit wrong in regards to my ISS observation, and we're going to go ahead and talk about it. I was supposed to have a debate with Antonio about this, but since he decided to piss Simon Dan off by being a transphobic piece of shit and is apparently too bitch me to debate me on my backup venue, I've just decided to say, fuck it. I'm going to just put Antonio in his place one last time and then wash my hands of it because I'm tired of explaining the same shit over and over and over again. So guys, this hangout, this stream, this presentation I'm about to give, this will act as the final nail in the coffin for Antonio, aka the lovable Dim Dim. So let's go ahead and jump right into it. Did I show that the International Space Station is not a plane and is indeed in space? See, this question focuses around an observation I did back in March of 2018, and this question also focuses on Antonio's stupid fucking objections to it. What I want to do here for this hangout is just go over my observation and the math that goes along with it, and go over Antonio's idiotic objections along the way. I'm sure that Antonio's objections are going to continue after this video drops, whatever the case may be. I really don't give a shit. But the truth is, you know, he's going to have to figure it out for himself from this point going forward. Because like I said, I'm fucking done here. I'm burned out with having to explain the same shit to Antonio over and over and over again. Now, the ISS, the International Space Station, the thorn in the ass of every flat earther in existence. See, the ISS has been observed by regular people over 2 decades now, but there's been a simple objection by the flat earthers to make it seem like it doesn't totally debunk their horse shit. You see, flat earthers, and I'm sure Antonio as well, they don't deny that you can see a light in the sky. But what they've decided to do is claim, based on no evidence whatsoever, is that the ISS is simply a plane at a very high altitude, or some drone, you know, shit like that. It exists, ladies and gentlemen, but it only exists to fool observers on the ground like you, me, and everyone else that happens to be looking in the sky at just the right time and in the right direction. See, flat earthers know that if the ISS does exist in the way that NASA claims, that it would be a severe kick in the dick for the flat earth conspiracy. Now, Antonio Subirats understands this, and this is exactly why he's been denying and fighting against the observation in question ever since I uploaded it to YouTube back in early 2018. So, what was the observation? See, I have a good friend. His name is Astronomy Live. You all may have heard of him. And I decided to give him a bit of a phone call and be like, yo, I have this good idea. Let's measure the altitude of the ISS for ourselves, and let's see if it's at an altitude that is impossible for a plane to reach. So, this is what we decided to do, and I hope you all enjoy. Now, this screenshot that I'm showing right here is the predictive path of a transit that was to occur in 2018, March 3rd, 2018 at 3:48 in the morning. You can use this transit finder by going to transitfinder.com. I'll leave a link to it in the description after this hangout is done and over with. But anyway, as you can see, you can find out exactly where you need to be in order to see the ISS go either in front of the sun or in front of the moon. So we said, hey, let's go ahead and do that. So that's exactly what we did. So here you can see the transit path in red, and over here you have observation point 1, and observation point 2. Observation point 2 is where Astronomy Live was standing, and observation point 1 is where I was standing just before the transit occurred. And this line is the transit path as it was predicted by Astronomy Live. So here you can see the green line, which is the distance between us, 1.106 meters. And then if you take these lines, which are at right angles to the transit path, you can get a point 1 to path of 435 meters, point 2 to path of 664 meters, point 1 and point 2 total 1,099 meters. And we'll be coming back to this later on because Antonio has a fucking problem with it, but moving on. So after the transit happened, we put our footage together and we noticed that the ISS transited a different part of the moon depending if you were at observation point 1 or observation point 2. The reason is because this is parallax. So because we have two distinct transit paths that span a certain amount of the moon, we knew that we were successful in getting a parallax measurement. And that was our goal. The reason why we were spread out over a kilometer is because we were trying to get this parallax measurement because with this parallax measurement, we can figure out the altitude of the ISS with the addition of one other piece of information from Astronomy Live's telescope, which again, we'll get into shortly. But here's how we did it. We did a bit of pixel counting and we figured that if we can count the pixels of how wide the moon is and divide that by how wide the transit path is, we can get a ratio, and that's exactly what happens. The moon was 962 pixels wide, and the span of our two tracks from center to center was 224 pixels wide. That equals a ratio of 4.29 to 1. So if you take 0.52 degrees wide, which is how wide the moon is, and you divide it by the value you just found, which is 4.29, you will get an answer of 0.1212 degrees. And this is the other piece of information that we gathered from that evening. On the side of Astronomy Live's LX200 telescope, there is this dial which tells you its altitude in degrees, the altitude in degrees of the direction that's looking. So what I'm going to do is I'm going to zoom in on this for you guys so you can see it. So right there you can see that at the time of the transit, the telescope was looking at 53 degrees. And just to repeat, the telescope was stopped only a second after the transit occurred. So that means we were able to get a parallax measurement and we were able to get a measurement of its altitude angle at the time of the transit. That was the time the ISS passed in front of the moon. So that was pretty bitchin'. Really good night that night. So parallax was measured at 0.1212 degrees. This was done by comparing the span of our two ISS tracks with the angular size of the moon via a bit of pixel counting. And again, I gave you the math of that early on, or earlier. Our baseline was about 1.1 kilometers, confirmed by Google Earth, and our altitude angle was measured to be 53 degrees. This was measured directly by the telescope. So, with all this shit going for us, how did we proceed from here? Well, what I did was I showed everyone this diagram. This diagram shows our two observers, Observer 1, Observer 2, Astronomy Live, and me. And if you follow our line of sight, you'll see that they cross at the International Space Station and they end up on different parts of the moon. This is why we have two separate tracks to work with, even though the observation happened at the exact same time. This right here is parallax. Also in my video, I went ahead and did the math to figure out exactly how far away the space station was from the center of our baseline. Now, if you take this isosceles triangle and you cut it in half, you will get a right triangle. And if you cut the values in half along with the triangle, you will actually be able to figure out what length x is. And we did that by 0.555 kilometers divided by the tangent of 0.0606 degrees, which gave us a value of 524.73 kilometers, or 326.05 miles. For the remainder of this presentation, we're going to stick with kilometers. But yeah, that was the distance from the ISS from us, the observers. Now you can work further from here and figure out the distance as it relates to the hypotenuse, like for example from observer 1, observer 2, and what is the distance from this observer to the ISS following this line. But it's roughly the same value, even to like 1 or 2 decimal places. There's really not that much of a difference. So 524.73 kilometers would be the correct answer for either observer 1 or observer 2, if you wanted to label it as the measurement of this line, which would be the hypotenuse of this right triangle. But with this value, we could add this in with the other triangle that we could build. Because we know that the telescope was pointed up at 53 degrees, that means we have another right triangle that we can solve. Since we know the distance from the observers, being us and the International Space Station, is 524.73 kilometers, finding the altitude is just some simple trig away. 524.73 kilometers times the sine of 53 degrees gave us an altitude of 419.06 kilometers, and that was without taking into account the curvature of the Earth. Now, 419.06 kilometers is an altitude that is impossible for a plane to reach. Spaceship One, if I'm remembering this correctly, had a altitude record of 110 kilometers, and that was a fucking rocket plane. And once that rocket plane got to that altitude, it could not maintain that altitude. The ISS is not only at a ridiculously high altitude, but it is maintaining its altitude. Kind of like, a spacecraft in orbit. Must be a coincidence, right, Dim Dim? But anyway, Antonio had a quick objection to all of this. And if we go back to this first triangle, you will see that in our original video, we used an isosceles triangle. But if you go to this slide right here, you will see that our baseline is not evenly distributed between myself and Astronomy Live. You will see that between Astronomy Live and the transit path, his line is a little bit longer, while my location to the transit path is a little bit shorter in distance between the two. So what he said is that the fact that we used an isosceles triangle pretty much invalidates our conclusion, because we should have used a scaling triangle. So I said, you know what? Fine, we'll go ahead and do just that. Let's go ahead and do the Antonio challenge. So this is Antonio's challenge. At the top, we have 0.1212 degrees. That parallax is never going to change. That is the parallax that we found on the night of the transit, so it needs to be added to this triangle. At the bottom, we have Astronomy Live side, which is 664 meters, and then we have my side, which is 435 meters. The challenge was to find length A, length B, and length C, since apparently Antonio claimed that it is impossible to find any of those values. I called bullshit, and a lot of people did as well. But why is this bullshit? Well, I'm glad you asked. Let's go ahead and figure this out for ourselves. The first thing I would do is bisect that triangle, making it into 2 right triangles, and I have to thank Antonio here for showing us how that is done after he claimed that it couldn't be done. Here you can see the comment, you cannot bisect a scaling triangle into 2 right triangles. Here we see him, Antonio Subirats, bisecting a scaling triangle into 2 right triangles. Here is the definition of bisect that we're using to divide into 2 parts. And hey, Antonio, did you take the scaling triangle and divide it into two parts, and those two parts were right triangles? Oh, you did? Very good. Have a cookie, dumbass. Anyway, so with that done, this is what we have. Now, there are many ways of solving this problem, and I'm going to go over multiple ways in this presentation, but let me just stick with this slide right here. The way I would solve this problem is that I would start plugging an arbitrary value for x until I got the original angle alpha that we know we got on the night of the transit. So this is the value that we're looking for. So the question is, what value can we plug in for x where the end result will be this value? That is the challenge. So I tried a few values. So for x here, I used 21.336 kilometers. This value right here is around 70,000 feet, which is the altitude of the U-2 spy plane. Now, if it were to be the case that x had a value equal to that of the altitude of the U-2 spy plane, we would get a parallax value of 2.949 degrees. That is way off from our original angle alpha. Well, let's go even further away still. Let's say x equals the altitude of the of spaceship 1. So 112 kilometers. Okay, if we do that, we get 0.5621 degrees, which is still bigger than the angular size of the moon, which means we wouldn't have gotten a parallax measurement in the fucking first place. So, 0.5621 degrees is not the same as the original angle alpha that we got on the night of the transit. Let's go ahead and plug in the original value that I had, which was 524.73 kilometers. Plugging this in for x, we get a value of 0.1200 degrees, which is an accuracy to within 0.9%, which is actually pretty good, especially for our purposes, considering we're not trying to shoot the damn thing out of the sky with a fucking cannon. So I am perfectly happy with saying that our original value is pretty good. I'm going to stick with that. So sticking with that, we have, of course, the 53 degrees that we have to add to our analysis, because remember, that is the altitude angle that we were looking. So plugging that in, we can go ahead and work backwards from here. So my original value was 419.06 kilometers. Let's see, do we get an angle alpha close to 53 degrees for this slide? Yes, we do. 52.9985, practically the same, good enough for our purposes. So working backwards and with a scaling triangle, we see that the values we get match pretty fucking close to the original value that I showed in my original video. So no, motherfucker, I didn't lie in my original video. The values are pretty damn close even with a scaling triangle. The conclusion is the same. The ISS is traveling at an altitude that is impossible for a plane to reach. But did this satisfy Antonio? Oh, of course not. Of fucking course not. There's always something more to bitch about. Look at this path. And look at this slide right here. Apparently, according to Antonio, there is a problem between these two. Can you see it? Are you seeing what Antonio is seeing? Why is this cause for concern? Well, according to Antonio, this is a big fucking problem, because if you look at the center line of our transit path on the Transit Finder site, you will see that it kind of goes like right here, and it just touches this little curve in the road right here, just kisses it. But on this one, you'll see that it doesn't actually kiss it, and it doesn't actually intersect this this road right here. So once again, going back, going forward, going back, you see how it like crosses over right here, and over here it kind of doesn't. Yeah, this line is shifted over just a little bit. And apparently, according to Antonio, that invalidates our entire observation. So I'm like, for fuck's sake, it doesn't matter where you put this line, where you put the transit path. It's not going to make that much of a fucking difference, but whatever. Antonio thinks that's a problem, so let's go ahead and solve this shit yet again. This is the new line. As you can see, this line kisses this little curve in the street right here, and it crosses over this road right down here. This is as accurate as I could get it while referencing the Transit Finder website. So, here's our baseline from Astronomy Live to that line, 573.38 meters. And here is the distance from me to that transit line, 529.03 meters as my baseline to that line. So, with that, we have a brand new triangle with brand new values. So, let's go ahead and solve this one. Will it make a fucking shit of a difference? Will it? Well, let's find out. 0.57338 kilometers on the side of Astronomy Live, and for me, 0.52903 kilometers for my side of the triangle. Value x, I'm going to put 521 kilometers and solve this out. So solving out alpha in purple is this right here. Sine inverse of 0.57338 divided by 521.000315512 equals, well, this. And for alpha in green, it's this. And then adding the two together, you get this, which is 0.1212 degrees. Huh, interesting. So what that means is that if you plug in 521 kilometers for value x, you get a value for angle alpha in red of 0.1212 degrees, which equals the original angle alpha that we found on the night of the transit. Cool. That means x in this case does in fact equal 521 kilometers. So with that, we plug that into our altitude triangle. And remember, we're working with an original angle alpha of 53 degrees. So 521 kilometers times the sine of 53 degrees equals 416.089 kilometers. So the altitude of the ISS using these fixed values is 416.089 kilometers without taking the curvature of the Earth into account. So, Antonio, are you starting to see a pattern here? It doesn't really matter what objection you bring. It doesn't matter in the long run because the conclusion is the same. The ISS is traveling at an altitude that is impossible for a plane to fucking reach. Look, we followed the original Transit Finder website, and we also followed the path that Astronomy Live predicted. Both of these come to the same conclusion. The ISS is traveling at an altitude that is impossible for a plane to reach. Get your fucking head out of your ass. Now, is there an objection? Oh, there always is. There's always an objection. So let's hear what Dim Dim has to say, because Dim Dim has something to say. Enjoy.
Here's their supposed targets for deriving values. So now we're going to look at what they should be working with to derive values. This is MoonCalc. This is red's location. This is the center line where the ISS transited, where you'd have the ISS, you're seeing it going directly over your head. And this is Astronomy Live's location. Exact. Now we're going to compare Astronomy Live to the center line and the center line to red. Pay attention to the moon azimuth. It's over on your left. That's what we're looking for. Astronomy Live's moon azimuth is at 234.35. The center line is 0.34 and red's is 0.33. That leaves 0.02 for their triangle to the center of the moon. That's right, it's as simple as that. Their triangle to the center of the moon has a 0.02 convergence point at the point where their lines of sight meet at the moon. That's the shape of their triangle. Whatever observations take place, they take place within that first.
Alright guys, I'm going to give you a moment to finish face palming. Sorry, take your time. I know the stupid is pretty raw, so just take your time and finish face palming. Or, you know, getting an oven glove and then face palming. Or smashing your face against your desk because of the stupid. Okay, so anyway, apparently Antonio has this idea that moon calc can tell you degree angles so that you can get parallax values to the center of the moon for the moon itself. And unfortunately, Antonio, that shit doesn't work like that. The reason why the azimuth changes is because of the curvature of the Earth. Congratulations, Dim Dim. You just discovered the curve of the Earth using moon calc. You dumbass. But, big buts here. We're not going to object to this value. In fact, we're going to adopt it. We're going to bring it into the calculations. And we're going to see, even with Antonio's fucked up parallax error, does it save his ass in any way, shape, or form? So let's go ahead and adopt this value in, shall we? First, let's figure out the distance to the moon with that value. I'm using an isosceles triangle for simplicity, and if Antonio has a problem with that, he can eat a dick. We are dealing with a asserted moon parallax, not really, but an asserted moon parallax of 0.02 degrees according to Antonio Subirats. So that would mean that if we plug this into our triangle and did the math, 0.555 kilometers divided by the tangent of 0.01 degrees, that means we would get a value for x of 3,179.915 kilometers. So at the time of the transit, that would place the moon 3,179 kilometers away. Now, when we originally did our parallax measurement for the ISS, we got a value of around 520 kilometers away, which is closer. So that means even if the moon was at this distance, which it fucking isn't, otherwise the angular size of the moon would be swinging wildly throughout the night, but I digress. Even if the moon was at this distance, the ISS is closer to us, so it can still pass between us and the moon, and we can still get a parallax measurement. The worst that this is going to do for us is add a 0.02 degree error to our original parallax measurement. So what I'm going to do is I'm going to give him this parallax error. I am going to add it into our equation, and we are going to see if this helps him in any way, shape, or form at the end of the day. So the way that this would benefit him the most is to add it to our parallax measurement, so that's exactly what I did. So here we go. The new original angle alpha is 0.1412 degrees. This means that the ISS will be solved out to be slightly closer to us after everything's said and done, but I digress. So we have 0.57338 kilometers for Astronomy Live side, and we have 0.52903 kilometers for my side of this triangle. Plugging in a value for x of 447.3 kilometers, we get a value of 0.1412 degrees. Here's how you would solve that using cosine, here's how you would solve that using tangent, and here's how you would solve that using sine. So we know that value x in this case equals 447.3 kilometers. That would be the distance the ISS is away from us at the time of the observation. So we plug this value into our other right triangle, the one where we're looking up at 53 degrees, and we get a value for its altitude of 357.22 kilometers. 447.3 kilometers times the sine of 53 degrees equals 357.22 kilometers. So, even if we give Antonio his fucked up parallax error value, we still end up with an altitude that is 3.2 times higher than Spaceship One, which is a rocket plane. And keep in mind, once Spaceship One gets to that altitude of around 110 kilometers, it can't maintain that altitude. The ISS is at its altitude and is staying there. It's maintaining it. So, Dim Dim, for the final two objections that we're going to be going over, we will be using a video from Where's Wally, who has already addressed them. Now, the first clip is regarding some epic dumbfuckery on your part, where you claim that we could fake the parallax by simply combining two separate observations from two separate nights. Antonio, are you high? What the fuck? Let's go ahead and I'm going to go ahead and play a clip, and then Wally's going to tell you the problem with that conjecture.
Okay, now we're going to look at how from this, which is their supposed observation, you can you'll be justified in assuming that these were two individual observations, not a joint effort. They're not the same distance away from the center line, they're not at right angles to the center line. In fact, it could be two separate observations on two separate days.
Two separate observations? Really? It is not possible that the ISS will be over the same path at all. Have you even looked at the path, the tracks that the ISS takes on consecutive days?
I don't know.
It's not even the same.
I don't know.
And the moon's lunation will be different. Someone observant like Antonio Subirats would notice that.
I don't know.
And it's going to be 13 degrees away from where it was the night before, so Antonio Subirats would notice that.
I don't know.
And the weather could be quite different. There's just really no way that you could make two separate observations on two separate days. But I tell you what, the one thing that does make sense is two different observations at the same time on the same day for the same pass of the ISS. That is just simply the easiest way to do it.
I don't know.
And also, one more thing, Dim Dim. Did you also forget that I was on the phone with Astronomy Live at the time of the transit and the cameras at both locations picked up the audio? Hey, Antonio, let me play that clip for you one more time just so you can listen really, really hard.
10 seconds. 10 seconds.
All right.
Transit.
Boom, saw it.
Yes, yes, transit.
Telescope stopped.
10 seconds. 10 seconds.
All right.
Boom! Saw it! Stopping telescope. Telescope stopped.
Yeah, that's right, Dim Dim. Forgot about the audio, did ya? Well, for the final objection that you have that we will be going over, I am just going to pass it off to Where's Wally, who will finish you off from here. Alright, Wally, take it away, good sir. Take it away.
Huh, it's interesting. You could have just parked on this road, walked down, and set up there. But no, don't need to. Especially if you're not going to actually take angles into account. So you see here, this is where astronomy life was. It could have been over here. Huh. Good Lord. Globe beings lying and distorting. Oh, would have thought of that.
You do realise, Dim Dim, that the small misalignment doesn't change the answer at all. The effect of that misalignment is that the transits are a few fractions of a second further apart. It's a discrepancy in time, but not in space. They accounted for any slight potential discrepancy by measuring the distance to the centre line at right angles.
All right, Dim Dim, that's it. I'm calling it here. And just Jesus fucking Christ, it's clear after this entire episode that you don't know trig to save your fucking life. You don't understand the concept of our observations. You don't know how to use moon calc or what it actually means. I mean, you don't understand anything about this observation. But you may not be a complete dim-dim. It could just be that you know for a fact that this observation is legit and the conclusions that we got from it are legit, and you just don't want to accept it. See, dim-dim, at the very least, I think you know what this means for your conspiracy. If the ISS is what NASA claims it is, then your conspiracy just got kicked straight in its dick. And you don't like that. You need to find some excuse, something to clinch onto where you can just cover your eyes and plug your ears and just go nuh-uh all day long and just keep yourself ignorant. You want to keep yourself ignorant. You want to keep your viewers ignorant. You want to remain in the dark when it comes to the awesome shit that NASA has been able to accomplish with the International Space Station. So, if you want to go ahead and live in perpetual ignorance your entire life, that's fine. That's fine. But if you continue to post bullshit, people are going to call you out. And rightfully so, because, hey, you speak like liars are the worst thing to ever scourged this fucking planet ever since AIDS and the bubonic plague. You know what? Liars do suck. So I have a tip for you, Antonio. How about you quit lying, both to yourself and your audience? How about you learn a little bit of trig? How about you actually do the math, which is what I've been telling you to do for the past, I don't know how many days. Do actual proper observation, experimentation, and mathematics. Do it right. And your first step is getting your head out of your fucking ass. Alright, that's it. Thank you all for watching. This has been great. This has been fun. This has been real. And with that, have a good night.